Hey everyone, in this video we will be going over predicting products for the remaining two types of chemical reactions, specifically single replacement and double replacement. So let's get started. As a reminder, anytime you're working on a predicting products problem, your first step is always to classify the type of reaction. Then once you've classified it as one of the 5 types of reactions, you'll use the guidelines on your reference sheet and your ability to write chemical formulas to predict the products. So remember, those are kind of like the laws of nature, thinking about diatomic elements, thinking about how different atoms are going to come together to form ionic compounds and things of that nature. That's in your predict step. The final step is always to balance. Okay. If you are ever in a situation where you cannot balance, like it just won't happen, then that means you probably did something in this predict step wrong. You need to go back and double check those formulas in order for it to properly balance. So we're going to start with single replacement for this video. Single replacement reactions are when we have one element displacing another element in a compound. So you can see from our diagram up here, A plus BC, A kicks B out of that reaction. So now it's, or excuse me, out of that compound. So now it's AC plus B. Notice that the A stayed in that first spot. So metals only replace other metals or hydrogen. So hydrogen when it is a cation. Okay, specifically a cation is when a metal can replace it. So metals only replace other metals or hydrogen. There is something called the activity series that will tell us whether or not single replacement reactions will happen. So not all reactions or not all metals have the ability to kick out metals from compounds. There is kind of this food chain of metals that tells us which ones have a better ability to kick other metals out of compounds. For our purposes, all reactions will happen. Okay, all reactions will happen. I just wanted to mention this activity series so that you have heard of it if you go on to take, AP chemistry or AP biology or something like that. The activity series tells us that not all metals are strong enough to boot another metal out of a compound. But for our purposes, we are going to assume that that activity series has already been looked at and all the reactions we look at will happen. So let's do some examples. So here's my first example. Calcium sulfate plus potassium. So my classify step, okay, we are in the context of these specific examples, so I know it's a single replacement reaction, okay? So I'm going to move on to the predict step. Potassium is the metal that's all by itself. I know it's a metal because it lives on the left side of the periodic table. It is going to try to kick the metal in the compound out. Okay, it's going to kick out calcium, and then calcium will be stuck out on its own. So it doesn't matter what order you write your products in, because the plus sign is just saying it's all of those things. It doesn't matter which order you put them in. So calcium's stuck out on its own, and now I'm going to have the compound of potassium sulfate. Sometimes it helps to think about the name of it to then be able to translate it to the appropriate formula, because I can't just put KSO4. That's not the correct formula for potassium sulfate. I need to use my understanding of formula writing. So potassium lives in group 1, so it is a +1 charge. It has that one valence electron to give. Sulfate needs 2, right? So it has a -2 charge. So I actually need 2 potassiums to even out that sulfate. So my formula there is K2SO4. So that's my predict step. So I'm going to go ahead and rewrite this reaction in a way that's now conducive to being balanced. So there are my reactants, my products, calcium bumped out on its own, and then the proper formula for how potassium and sulfate would come together. All right, to balance this, we have one calcium, one sulfate, one potassium, two potassium. So this is actually pretty straightforward to balance. We put a 2 in front of K to balance that out. Remember, you can leave the rest of these lines blank, or you can put the ones on the line, whichever you're most comfortable with. Okay, but the biggest thing here is that we did write the proper formula for what this new compound looks like. Okay, if we continue to use those relationship analogies, we can think about the fact that, potassium's relationship with sulfate might look a little bit different than calcium's relationship with sulfate, and that's okay. But we need to figure out what that relationship, aka the formula, looks like. Our second example is a little bit different. It is still a single replacement reaction, and I'm classifying it as a single replacement reaction for two reasons. One, this is the single replacement example, right? It's the context I'm giving you. But two, I have an element plus a compound. So that element is likely going to try to take a spot in the compound. However, this is a little bit different because the compound here isn't a traditional looking ionic compound, it's water. So we need to actually reformulate water and write it in a different way so that it looks more like an ionic compound. So the way we do that is we write it as hydrogen hydroxide. Okay, we still have two H's and an O, but now it looks more like hydrogen bonded to hydroxide. So this is a little bit more clear now to be able to rewrite the products. Sodium is going to take the place of this cation hydrogen, and it's going to be bonded to the anion hydroxide. Then hydrogen gets kicked out on its own. So my products are essentially, if I were to write them in words, right, are going to be sodium hydroxide and hydrogen. So let's translate those to the appropriate formulas. So again, I'm going to write this out. Okay, sodium hydroxide. Sodium has a +1. Hydroxide is a polyatomic ion that has a -1. So that formula is going to look like this. And then hydrogen. Hydrogen is part of that Honkelberg club. It is a diatomic atom, so it has to be H2. Okay, so to kind of recap here, we needed to treat water as more of an ionic compound, so I rewrote it as hydrogen hydroxide. The sodium then can kick out the cation hydrogen to bond with the anion hydroxide to make sodium hydroxide. Then the hydrogen is kicked out on its own, and hydrogen, when it is by itself, it is diatomic. So this is my predict step, okay? I would recommend keeping your water as HOH to balance because that'll make your life a little bit easier. So if I go ahead and put my little blanks out front to be able to balance, one sodium, I have one hydrogen out front. I have two of those hydrogens over here. Okay, so I'm going to go ahead and put a 2 on this line. Let me get a different color going. That gives me 2 hydroxides. So I need to do that, and then I need to fix the sodium. So 2 sodiums, 2 hydrogens, 2 hydrogens, 2 hydroxides, 2 hydroxides, and we should be good to go. So I can put the 1 there if I want. So notice I can kind of separate out this hydrogen from the hydroxide, which made that balancing a little bit easier. So you can do that or not do it, keep it as H2O. You still should get these coefficients in your balanced reaction, 2, 2, 2, and 1. Let's move on to double replacement reactions. So double replacement reactions are when we have two compounds and they swap partners. So we can also think about this as the cations switching places. Okay, each compound will always have a cation and an anion. There's always a positive piece and a negative piece. The new compounds in the products should also still have a cation and an anion, and they should still always be written in that order. Positive piece, then negative piece. Always, always. Okay. We also need to make sure that we're maintaining the charges from the reactants to the products, specifically for the transition metals. So what that means is we're going to have to work backwards to figure out what the charge on the transition metals are in the reactants and make sure to use that proper charge when I write the new formulas in the products. We need to write new formulas in the products because these new compounds have to be properly balanced. We have to write the new partnerships the way they should be written using proper ionic formula writing techniques. Okay. The other thing I wanted to point out is the formation of a precipitate is the main type of this reaction. We are not going to get into what that is and how to determine the precipitate and things like that. That will be something you'll see later on in AP if you take AP. So for right now, we're just going to be worrying about predicting the basic products. So here's my first example. Again, I'm going to classify it first. So my first step is to say, okay, this is a double replacement reaction. I know that I have two compounds. The cations are going to switch places. Okay, that means I'm going to be using, this generic equation to guide me. All right. So sodium chloride plus silver oxide. Sodium is going to take the place of silver and be paired with oxygen. And silver is going to take the place of sodium and now be paired with chlorine. I'm going to rewrite this. Oops. I'm going to rewrite this with some different colors going on so that we can kind of see what's happening. So I'm going to put NaCl in green. And then I'm going to put Ag2O in blue. And we're going to kind of see what happens over here. So I like to rewrite the ions in those appropriate colors. So I'm going to have Na, well, let's do this. Cl and Na are going to switch. Ag is going to be over here. Oops, that's really close. And O is over here. Okay, but I got to include their proper charges so that I can write proper formulas. So notice I'm writing these a little bit above where my products would go. Okay, when I do this then, Ag is a +1, Cl is a -1. So this is going to be Ag, Cl. They're going to form a 1-to-1 ratio in that compound. All right, and then the second formula here is going to be Na is a +1, O is a -2, so I'm going to need 2 sodium ions to even out that oxygen. So Na2O. Notice I have my green compound, my blue compound. I have one blue, one green, one blue, one green in both of the products. But also notice that I took the steps to figure out what these new compounds were going to look like by finding their charges based on where they live on the periodic table and figuring out the ratio they would combine in. That is absolutely essential when you're doing these types of problems. You have to write the new formulas using their appropriate charges. So I'm not quite done yet though, because my last step is always to balance. So I'm going to rewrite this just in one color with my blank, so I have NaCl plus silver oxide. Okay, we can think about this in words too, is then going to make silver chloride, which we wrote the appropriate formula for, and sodium oxide, which again, we wrote the appropriate correct formula for. So last step is going to be to balance. I'll go ahead and balance in purple so that I have finally a completely different color. One Na, I have two NAs over here, so I'm going to put a 2 on this line to match those, two sodiums. That also means I now have two chlorines, so I'm going to need two chlorines on the right, two silvers on the left. Well, now I have two silvers on the right, and one oxygen, one oxygen. So I can put the ones on these other lines if I want, or I don't have to. But two sodium chlorides plus one silver oxide will produce or yields two silver chlorides and one sodium oxide. Let's do another one. All right. So again, we're classifying double replacement, giving you that context. Great. Now I need to figure out what the new products are. So the metals here are magnesium and copper. So I like to just kind of think about them switching places. But again, they can't just swap. They have to swap properly by writing the new compounds. So let's think about this for a minute. Copper is now going to be with nitrate. Nitrate is NO3, which has a -1. But what the heck is copper's charge? Well, I have to kind of work backwards and think about what copper's charge is. So I'm going to do that over here, right? I have one copper and I have one sulfate. Sulfate is always, always, always -2, right? That's what it says on the reference sheet. However, copper is a transition metal. We don't know what its charge is unless we use its situation. Its situation in this case is one of them balance out the one sulfate. So that means its charge has to be +2. If these are coming together in a 1-to-1 ratio, each copper ion has to have a +2 to even out the -2 of sulfate. So this is what I was referring to when we think about charges carrying over from the reactants to the products, particularly for the transition metals. Then the other pieces I have are magnesium, which has a +2, and sulfate, which has a -2. So now I can write those formulas, right? So if copper is +2, that means I'm going to need two nitrates to even that out. Magnesium and sulfate, a +2 and a -2, are going to bond in a 1-to-1 ratio, right? This is a 1-to-2 ratio. This would be a 1-to-1 ratio. So those are my products, right? Copper 2 nitrate and magnesium sulfate. So if I rewrite that down here with the appropriate, so if I rewrite that down here with our blanks to be able to balance, MgNO3, 2, so magnesium nitrate, plus copper 2 sulfate. We used our reasoning skills to figure out what copper's charge is going to yield copper 2 nitrate and magnesium sulfate. All right, so now our last step is to balance. One magnesium, two nitrates, one copper, one sulfate, one sulfate. So this is actually balanced as it's written. So I don't have to put any coefficients in front of anything. This is all done and balanced here. I have one last example for you that is the other type of double replacement reaction that is given on your reference sheet. It is called an acid-base neutralization. Okay, we haven't talked about acids and bases yet, but hopefully most of you know that a neutral thing is water. Okay, so this is the acid here because it starts with hydrogen. This is the base because it ends in hydroxide. Again, I don't expect you to know that yet. We will talk about that soon. But this is going to help us think about what will be formed. So the cation here is hydrogen. The cation here is sodium. They are going to switch places. Whoop. So I will have sodium with sulfate, and I will have hydrogen with hydroxide. So let's look at what those charges are, right? Sodium lives in group 1. It always has a +1 charge. Sulfate always has a -2 charge. Hydrogen is +1. Hydroxide is -1. Hydrogen is +1 because it also lives in group 1. So if I rewrite these formulas, or write them properly, I should say, I'm going to get Na2SO4, that's sodium sulfate. And then I have HOH, one of each of those things. Well, if we notice, HOH, we broke something down as HOH in an earlier problem in this video. That is actually water. I'm going to leave it as HOH when I balance it, and then I'll rewrite it more formally in a moment. So H2SO4, that is sulfuric acid, plus sodium hydroxide is going to make sodium sulfate, which I wrote the proper formula for, and hydrogen hydroxide, also known as water. So let's balance here. I have 2 of these hydrogens in front. I only have 1 over here. So let's get a different color and balance that really quick. So 2 should go there, right? And then that's also going to give me 2 hydroxides. So I'm going to need to fix that on this side to make 2 hydroxides, 2 sodiums, 1 sulfate, 1 sulfate. So that then is balanced the way I have it written there. So I'm going to rewrite it in green here as the more proper way to write it, that I have water as the product. So when I'm talking about acid-base neutralization, that means we have water as one of the products. So you might see a couple of those examples as well. Make sure in all of these problems you're following these 3 steps: classify, predict, then balance. Make sure when you're predicting, you're writing formulas, use your understanding of formula writing, please, 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 because otherwise you're not going to be able to balance these reactions. All right, good luck on your practice. Let me know if you have questions. Thanks for watching.